vector fields. The goals in this section to sketch a vector field, number one. Number two, to find the gradient vector field of a function. Okay, so what the heck is a vector field? Well, okay, in words, a vector field f is a function that maps points to vectors. So to represent this symbolically, we could say f of x, y, two ways to say it. If we're mapping a point in R2 to a vector in R2, then the input would be just x and y. And we could think of the I component as a function of x and y. We'll call it p. So p of x, y times I. And then we could think of the j component as a function of x and y too. We could call that q of x, y times j. Or you'll often see me write it without the function notation, just in component form, saying p comma q, with the understanding that p is a function of both input variables and q is a function of both input variables. And then, so we're mapping just a point to a vector, and we really do think of that vector as an arrow here. And if you think about it, what we're actually doing looks a lot like a transformation. We're mapping a point in R2 to something else in R2. But now we're thinking of it, with a transformation back in 15.9, we mapped a point to a point in the UV plane to a point in the XY plane. Even when we use vector notation, that's what we weren't thinking in terms of arrows. Here we're thinking in terms of arrows. We're mapping a point to an arrow. Okay, so that's the difference. And then that could be done in the plane, as this one suggests. So this would be a vector field in the plane. And then, of course, you could map a point in R3 in space, f of x, y, z, to a vector in space, which you could represent as p of x, y, z for the first component. So p of x, y, z times I plus q of x, y, z times j plus r of x, y, z times k. Or sometimes we like to go back to component form and just keep it simple, p, q, r. With the understanding that p, q, and r are functions of the input variables x, y, and z. Okay, so this would be a vector field in space. So let's look at a few examples. And in fact, we're going to graph a few examples. So the directions in this example, sketch f, about the easiest thing you could hope for is a constant vector field. So no matter what the inputs are, x and y, the vector field's a constant. 1i, or just I plus 2j, is the same as 1i plus 2j, or in component form, 1, 2. So you always get the same vector no matter what the input. That's about the easiest vector field I can think of. And the way we map a vector field is we make the input point the tail. So I pick a point. Let's say that's my input right there. I don't care, what am I, a 1, 2, 3, over 3, up 3, I don't care. But let's say my input is 3, 3. In this, it's only this one I don't care because the vector field's a constant. Doesn't matter. I'm going to go from that tail, I'm going to go right 1 and up 2, right 1, up 2. All the vectors, no matter what the input's going to be, are going to look the same. And so I don't really have to pay much attention to what the input is. Wherever I pick my point, I go over 1, up 2. Over 1, up 2. And so, over 1, up 2, you get this effect that, I don't know, maybe it looks like the current. Maybe it looks like we're modeling the current in the river, and it's all, there's no eddy currents or anything. It's all going in a uniform direction, kind of slanted like so. Over 1, up 2. That makes sense? Over 1, up 2. So it's super easy to plot a constant vector field. Any questions on that? But do you think they're all going to be constant? No, that wouldn't be very interesting, would it? Part B, here we have f of x, y equals y times j. which if you prefer component form, we could express as what? What components would this have? 0, y. So this one we have to think a little bit. So if I made the input 2, 0, what's the vector? Well, what's the y component of this point? Well, I don't want to draw an arrow there. I was about to draw an arrow to point at the point, but that's probably not a good idea. So this point, this input, so if you wanted to make a table, you could, although I won't do that too often. So the input is a point, like x, y, and the output in this case is a vector 0, y, right? Okay. Then if the input is 2, 0, now you can see what the output is. What's the output going to be? The y value is 0. It's 0, 0. So is that a very interesting input? The 0 vector doesn't have any length to it. It's just a dot. So that's a pretty boring input. We should try something else. What if, in other words, one with a non-zero y? So what would say something along the y? I don't think the y, if a y has a non-zero value, it'll map to something. So what would a vector along the y-axis look like? Say at, let's use an input of 0, 1. What would that map to? Same y value no matter what, right? 0, 1. Oh, so the input would map to the corresponding vector with the same coordinates, wouldn't it? That's kind of weird. Okay, so we would, from this, make the input the tail, and then go over 0, up 1. So like that. But what would it look like if we made the input 0, 2? You'd go up the y coordinate. The x coordinate's always 0, right? That's what this says. X coordinate's always 0, so it's always a vector pointing straight up. And its length is going to be basically the length of the y coordinate, right? So it would be the vector 0, 2. So maybe I don't want to do it right there because it looks like it's connected. How about if I input 0, 3, then how long what should the y coordinate be? So you input 0, 3, that should go to the vector 0, 3, right? So that would be from that input point 0, 3, you go up 1, 2, 3. But then what if you went down? What if you used an input of 0, negative 1? Then what's the output? A vector 0, negative 1, right? So it would look, you'd go over 0, but in a down 1, wouldn't you? Or if you put in 0, negative 3, 1, 2, 3, you'd go in the direction of negative 3, 0, negative 3. So over 0, down 1, 2, 3. Like that? Does that make sense? What if I made the input, I think you got the idea, but what if I made the input, what is this, 2, negative 1, 2, 3, 4? Then the x coordinate's always 0. What's the y coordinate? If the input y is negative 4? Negative 4. So I go 1, 2, 3, 4 down there, like that. Or if I input 2, 1, oh, it's going to look, along any horizontal line, they're all going to look the same, aren't they? Ah, now you found a quick way to graph a whole bunch. All right, I think you get the idea, right? Okay, and you could keep doing that the rest of your life, and you wouldn't get the whole vector field, right? So I'll stop on that one.